Hi, welcome back to everybody who is joining us again. It's great to see so many repeat participants for our webinar this week. I also see that we have a couple of new people joining us, so welcome. Hopefully you have a good experience today. As we get started, I just want to introduce myself. So my name's Karen Sauer. I am a senior professional development provider here at the Museum of Science in Boston, and I am part of the Engineering as Elementary team. So the webinar that you guys are attending today is our integration of STEM subjects in elementary classrooms. During this session, our webinar goal is to investigate what it means to meaningfully integrate STEM subjects. So instead of having this as a checklist of did I do my science, did I do my technology, my engineering, and my math, hopefully we can think more about what meaningful integration would look like in a classroom and give you some tips going forward to help you out with your planning for the upcoming school year. As we get started, again, this is a review for anybody who has been with me this whole week, but I do want to just go over our participant status. We use this at the end of classroom videos to confirm that the video has ended on your end, because we find that different computers have different buffering times, and sometimes it takes a little longer for somebody to get to the end of the video. So this is to help ensure that most people can see the video without a problem. All right, so at the top of your screen, you have a little person who's waving at you, and you can see it here on my PowerPoint. What you're going to do is you're going to click on the drop-down menu, and it gives you a number of choices to choose from. If you can click on the Agree button, it changes your status to Agree. And what I want us to do is I want us to all give us practice doing that, so that way I know that everybody can communicate with me through their participant status. There are some other options there as well, and if you'd like to use those, you're more than welcome to. Great, it looks like just about everybody has successfully changed their participant status. So let's practice clearing our status as well. You're going to go back up to that little person waving at you, and you're going to select Clear Status. All right, great job. It looks like people are clearing their status. Thank you very much. All right, so jumping into our content this afternoon, I want to pose this first question to all of you, and we're going to answer this question in the chat pod on the left-hand side. I want you to think about, how does the addition of multiple subjects add value to a lesson or a unit? So when you're thinking about integration and we're thinking about the value that integration has, what is that value? What do you look for when you're adding multiple subjects together? So I'm going to give everybody a chance to write this down in the chat pod. Okay. And it looks like we have a couple of people typing in, so I'm going to give them a chance. It adds interest. Yes, definitely. Interest for who, though? Interest for the teacher, interest for the students, maybe a little bit of both. Both, exactly. We want it to be interesting for us as the educators or as the facilitators, and we also want it to be interesting for our students or our learners. It helps the students make connections between subject areas. A lot of times they think about, well, I'm doing math now, I'm doing science later, and they don't always see the way that the subjects are interconnected. So really integrating and layering our subjects together allow the students to see those connections. So connecting to real world, making it authentic, to practice. The students understand why I should know this. It moves class away from just memorization and hopefully moves it into more reasons for doing things. So they can apply their prior knowledge, connect it to what they're currently learning. These are all really great things to think about when we're adding subjects together to create a whole learning experience for our students. So I see a couple of people still typing in, so I'm going to give them a chance to finish adding their thoughts. Great. Right, so again, the prior knowledge, and see that everything is interconnected. I think these are all really important things to think about. So what I want us to do now is I want you to think about, what does it mean to actually describe a meaningfully integrated lesson. So what you're going to do at this point is we're setting up a word cloud, and I want you to think about what words describe a meaningfully integrated lesson. If you think about, what you're looking for in a lesson that combines more than one subject, what are those things? So we have our word cloud all set up. You can actually start typing in the chat pod, and as you add your thoughts in, we'll start to see a growing word cloud. Great. So cohesion is really important. The students see the connection, and the cohesion for the integration is, if everything works together, we've got that nice flow and that nice cohesion. If it's just we're tacking things on, the lesson or the learning experience might get a little choppy. Transdisciplinary, engaging, increased motivation and motivating. Right, relevance, multicultural, motivation again. If you see a word down that you think about and you're like, oh, that's the word I would have said, feel free to type it in again, because that helps certain words really jump out during this word cloud experience, because it makes it known, like you find this to be really important. All right, I'm going to give a couple more seconds because we do have a number of people in the room, and I'm hoping that giving people a little more time to think about it will help us add to this word cloud. Because what I really want to do is I want us to be able to come back to this word cloud at a later point in this webinar, and we're going to be able to compare it to our growing understanding. So I'm going to give people maybe another 10 seconds to contribute. Problem solving, engaging, right. And again, if you see a word out there that you also agree with, put it in again. It's going to make a difference in the way our word cloud looks. All right, so it looks like, okay, we have a couple more coming in. We are going to download this in a second, so get your final thoughts into the word cloud. Real world, confidence. And once we have this down, okay, we're going to take another second before we download it, because it seems like people are jumping in, and I want to give everybody a chance to throw in their thoughts. Relevance has gotten really big. Relevance and engaging, multicultural, all of these words have gotten really big, which is great to see. All right, so I'm going to ask that I have two people who are on staff with me behind the scenes, Shava and Matthew, and they're working to make sure that all the technical aspects of this webinar are running smoothly. So I'm going to ask them to download this word cloud for me, and once they're done downloading it, we're going to move on to the next part of our webinar. And just to give you a little preview, what we're going to do in this webinar is we're going to look at a couple of different scenarios of integration. We're going to kind of discuss it and chat about it a little bit. And then at the end, you guys are going to have an opportunity to offer some suggestions to a teacher on how they can maybe more meaningfully integrate their lesson. All right, so it looks like our word cloud is downloaded, so I'm going to move us on. All right, so in this, what I'm pulling up is an integration scenario. So this is scenario 1, and these are just the standards to start with, and I'm going to explain a little bit more. But as you read the scenario, which will be on our next slide, I want you to consider, does the integration of STEM and engineering add value to the lesson? Have they worked together seamlessly to be cohesive, using one of the words you guys shared with me, to actually create a meaningfully integrated lessons for the students? So this is a life cycle lesson sequence. The teacher is focusing in on a science standard of developing models and an engineering standard of defining a simple design problem. So they've pulled both of these from Next Generation Science Standards. This is just to set a little bit of the context for us. And here is the scenario. If the scenario is a little too small for you to see, if you go to the top of this pod, there is a set of 4 arrows that are all pointing outward. That will actually make this pod bigger for you on your screen only. So feel free to use that feature if you are having a hard time reading this. I know if you are joining us on a mobile device, sometimes the device is a little too small for some of these things. So I'm going to give you a chance to read through this scenario. And again, as you're reading through it, I want you to contemplate the question that I've posed on the bottom left of your screen. Okay, does the integration of the science and the engineering add value to the lesson? When you have finished reading through the lesson, I am going to ask that you just change your status to agree because it is a lot of reading, and I'm going to actually be quiet in a second to give you some quiet reading time. But as soon as you're done, just change your status to agree so I know to continue. So it looks like a bunch of people have changed their status to agree. If you finished reading, please change the status to agree so that we know you're ready to move on. Okay, it looks like most people have changed their status. So great. If you haven't, you can continue to read it as we move on. What I want you to do now is I want you in the chat pod below, I want you to answer the question that you were considering. Does the integration of science and engineering add value to this lesson? And if your answer is yes, I want you to explain why. And you know what? If your answer is no, I also want you to explain why. I want to know a little bit about your thinking of, do you think it adds value? Why? Why not? And any possible thoughts on how to, improve the value if you're seeing something missing. All right, so I'm noticing a lot of people typing in, so I'm just giving people time because I know that this is more than a quick answer. This might require a sentence or two to answer the question. So I'm seeing them starting to come in, which is great. So as they're coming in, you can also read what other people are saying. Great. All right, so the students are using what they know about science to create their designs. They're integrating the science standard by looking at the habitat activity. They're adding in a little bit of math in there as well. So yes, they have a little bit of extra information. The students learn how to solve real-world science problems using the engineering design process. Okay. Okay, all of these are really great thoughts. And I see more people typing, so I'm going to give people a chance to continue adding in what they think about this. And then also, we do see some math in there, which is really interesting. The students have created a graphical representation. Would you consider the math to be meaningfully integrated in this situation? I know it's not the subject you were looking at, and it's not the subject the teacher was addressing, but is it as meaningfully integrated as the other two subjects? A lot of people typing in, so I'm going to give them a chance to complete their thoughts. All right, so again, good thoughts. So yeah, if this is something that the students are currently working on in the math, it might be something that's meaningful to them, and it might be connecting. But other people are thinking that maybe, you know, if this is, it's new information and it's an interesting look, but maybe it's not as meaningful as the other subjects are because it's just kind of in there as a way to address the science. It is age appropriate, which is right as well. Okay. All right, so you guys have had a chance to really discuss, and you guys have been really reflective. I love all the comments that you've provided. We're going to move on and take a look at another scenario. So this time, this new scenario, the teacher is focusing in on math and engineering. So this is a 5th grade unit on water filters, and the teacher is focusing in on math of known relative sizes of measurements, focusing in on the measurements, and then their engineering standard is generating and comparing multiple possible solutions. Okay, so this is just to give us a little context as we move forward to look at the lesson itself. All right, so again, this is a lot of information. So I'm just going to share a little bit more about it, and then I'm going to mute my mic so you have a chance to read the activity. And again, when you're done reading, just change your status to agree so we know that we can continue with our conversation. Actually, here, let's move here for now because I want to give everybody a chance to read without people starting to type in. All right, so I'm going to turn my mic off. You guys are going to have a chance to read. Again, make sure you change your status to the agree button so that way I know I can move us into the chat layout. So it looks like most people have finished reading. If you're still in the process, you can continue reading. I'm just going to move us to our next layout so that way the chat pod is available for us to make our notes about this scenario now. So again, what I wanted you guys to think about was how does the integration of math and engineering add value to this lesson? And so I'm going to pose the question again. Does the integration of these two subjects add value to the lesson? And if the answer is yes or the answer is no, I'd love to hear some of your thoughts on why or why not. I see a lot of you already jumping in to put your answers in the chat pod, so I'm going to give everybody some time to do that. Okay, you guys must be writing a lot. I'm looking forward to seeing what thoughts you have about this unit itself or this lesson sequence. Yeah, I like the connection back to the community there. I think that's really nice. That they're looking at, water filtration in communities around the world maybe, or just communities in general and comparing them, and then using that information to help them with their design. And right, using the math, collecting some data, so gathering some data so that way they can make informed choices about their design. That's something that I really look for in an engineering challenge is I want the students to be able to make an informed decision. I don't want them to make most of their choices based on trial and error. I want there to be some reflective thought behind something they're choosing. So having that math there, really talking about the rate of flow, gives them an opportunity to look for something like that. Yep. Yeah, this is math applicable to the real world. I mean, a lot of times some students look at math and they're like, well, when am I going to use it? This is a great case where you're using math to assess the success of your engineering, the technology that you've engineered. And right, having the students be accurate with their math. And it is, yeah, it's everyday math. I like that as well. The fact that it's accessible math, they don't have to worry about it being, too hard for them. They're just looking at rate of flow. Anytime you can apply math, I think that makes all the difference because I remember spending so much time in the classroom just memorizing things, and it was always so much more interesting when I had a chance to apply what I was learning to something that I found engaging and exciting. So, right, again, this collecting data, a lot of you are pointing this out, and I think this is a really great point to make. And I think this is something for us to really think about when we're deciding what meaningful integration means for ourselves and for our students, is the use of the math in this experience is so relevant and so connected to the student's outcome. I think that's lots of great thoughts here. So I'm going to give people a couple more seconds. It looks like we have a few more people adding some thoughts, and I want to make sure I give everybody a chance to contribute to our larger conversation. All right, great. Yeah, and the fact that math and engineering skills can be applied in so many different situations. And I like thinking about them as skills because you're gaining these things and hopefully you can find uses for them and apply them going forward. All right, so now that we've had a chance to see both of these scenarios, I actually am setting us up so that way we can look at both scenarios at once, and I've kind of shortened the descriptions a little bit to fit better on my screen. Again, if you're joining us from a mobile device, sometimes these screens are a little small. You can actually enlarge things on your screen. It's not going to impact what I see or what anybody else sees. But you can do that by clicking on, there's 4 arrows at the top of each pod. That will make the pod bigger so you can see it. So what we have in this in this layout is we have scenario 1, which was our life cycle scenario. Above that, we have all the comments you guys added to our conversation. And if you want to scroll up and down, you can. So there's that scroll bar on the side. Again, feel free to move that around. And then water filters is on the right-hand side. And so I want us to think about what are some common attributes of both scenarios. So if we had to start listing common attributes of meaningful integration, thinking about the two scenarios that we were assessing and discussing, what are some common things we're noticing? And again, you can go back to the comments people previously made and look and see what they were saying. And you can also see the short descriptions of the scenarios at the bottom of the screen. So I see a couple people typing and pausing, but now there's more people typing. Great. So I'm going to give everybody a chance to write their thoughts. Great. I think a lot of these comments that you guys are adding are all interconnected in themselves. This idea of application of these subjects. The students aren't just doing things by rote, they're actually applying it in real world situations. They have a chance to get their hands on it, or I like to always think about it as get their minds on it or around what they're doing. So the students are actively participating in these experiences. They're using these subjects to solve real-world problems. And I think that's just a great thing for them to do. And we know that we want our students to be able to think critically. And this is a great opportunity for them to practice those critical thinking skills. Right, and again, the scenarios that we've offered here are very realistic. The students can connect them to the real world, possibly even to their own communities, which is really nice when you're talking about engineering and STEM in general, is being able to connect it back to the students' community and themselves. Right, so these are real problems that real people need to solve. Students have to use many of the subjects in order to solve this problem. They can't just say, well, this is math class, I'm only going to use my math skills. They have to understand that they have to pull from other subject areas to, get to their final product. And I love that. Thinking about seeing what real scientists, engineers, and mathematicians do. And I like the idea of do. I always think about, I want the students to do science. I want them to be engineers. I want them to, think like mathematicians. So these are all opportunities for them to do this. Great. Great. I love all this 21st century skills. There's usefulness in this learning. So these are all a lot of really good thoughts. And what I'm going to do now is I'm going to bring back our word cloud from earlier. And here it is. Again, some of these words might be a little small, might be a little hard for you to see on our word cloud, but I think the most important ones are the ones that are nice and large. Multiple people put these into our word cloud. And so I want you to compare the attributes, the common attributes that you have listed in our chat pod here. Think about how they compare to the words that we used earlier in this webinar to describe meaningful integration. What are some things that you're noticing about this attributes conversation that we're having, about the two lessons that we looked at and our word cloud that we developed? Yeah, they're very similar. I'm seeing a lot of overlap myself. The relevance is really important, right? You guys made relevance one of your bigger words. And if we look up and down your attributes chat, you really were talking about this real world application. Students are using math to solve a problem. They're applying their knowledge. They're thinking about their community. All of these things that you were describing earlier showed up in the two scenarios that we were looking at. engaging. Yeah, I really hope that both of these scenarios would be engaging, again, for both the teacher and for the learners in those experiences. Okay. So, great job making a wonderful word cloud earlier in this webinar. I like that it lined up really nicely with the initial scenarios we were looking at. What we're going to do is we're going to take a moment now to watch a classroom video. I'm going to set this video up to give you some context before we play it. So this video is from our Engineering's Elementary Unit, A Long Way Down, Designing Parachutes. This is our aerospace unit. And you're going to be observing Lesson 4, which is the design challenge. The students are engaging in the create step or the create stage of the engineering design process. They've already asked questions, imagined some possible solutions, worked together with their teammates to come up with a plan, and now they've had a chance to create, and they're going to be testing. So the students are designing a parachute that will fall at a slow rate while it is still small enough to fit inside of a spacecraft. So the reason why we want it to fall at a slow rate is the students are creating this parachute to fall on an atmosphere that is different than the atmosphere that is here on Earth. So the students are dropping their designs 3 times. So they are gathering 3 sets of data, and they're dropping them all from 15 feet. So there's consistency there in how they are collecting their data. During this design challenge, they also are gathering this data on a worksheet. So this worksheet is really small. I'm going to enlarge it in a second for you. But you can also see I have a little arrow pointing to the create stage of the engineering design process. And so just to give you a little more context of where they are. So this is their like kind of a close-up of the design challenge page. Again, if this is too small, you can click on that 4-arrow pod to make it bigger. But hopefully it is a good size for all of you. This is just giving them some information. They're going to be calculating their average drop speed, so they are putting in how far they're dropping it, which is the 15 feet. They are gathering their 3 sets of trial data, and then they're going to calculate their average drop speed rate, and they're going to fill in the remaining blank spaces on this handout. After they do this, they are going to be using that information that they've gathered from their trials to start improving their design. So the reason why we're actually watching this video, though, is I want you to think about which math skills are being practiced, and does the inclusion of these math skills add value to the science and the engineering in this experience. So this is a 4th grade classroom, as you can see on the screen. And as soon as I mute my mic, we'll start the video. Again, at the end of this video, please change your status to agree so that way I know the video has completed on your end. And if you want, you can start putting some notes in the chat pod, or if you want, you can wait till the end of the video to answer these questions. Okay. And I'm going to mute my mic, and we're going to play our video. It's about 1 minute and 15 seconds long.
Now that you have your 3 pieces of data, what you want to do is add them together, divide by 3 to get the mean, to the nearest tenth.
I got 17.
Each one of you calculate. Each one of you calculate under your paper. Everyone does the math.
17. Divided by 3.
Okay. Did you get an average?
Yeah, that's it.
That's the mean? Okay, so now 15 divided by that.
How do you do that?
I'm going to give you a
This
calculator.
one. Yay! divided by 5. Yeah, then you gotta round it to the nearest 10.
Nearest 10.
2.5862 0.68.
You're not gonna fit that in that little box. Oh my gosh.
Nearest 10th.
Okay.
Round it to the nearest 10th.
Alright. It's 2.6.
Yep.
Timer was stalling.
Almost everybody's video has ended. So thank you. So if you haven't already started, you can start putting some of your thoughts into our chat pod. So this is the question that we were thinking about, is what math skills were the students practicing during this lesson? And did the inclusion of these math skills add value to the science and engineering as a whole? So yeah, the students were working on their rounding skills. I mean, I thought that was a really cute interaction when they were reading the entire number off the calculator, and the one student was like, nope, that's not going to fit in the tiny little, you know, box or space that I have available to it. So the students needed to practice rounding, some addition, some division, because they're calculating the average or the mean. So they're really applying a lot of math skills, and I like the idea of fluency. We want our students to become fluent in, you know, our math skills, fluent in all of these skills, and the way that they're going to do that, the way it's going to become very natural for them, is giving them these authentic experiences to practice those skills. So as you guys are continuing to add your thoughts, I just want to point out some Common Core math standards that are being addressed in this video that we were just watching. They're not being met, which is something to keep in mind, that we're not teaching the students how to do these things. We're not, you know, that this lesson shouldn't be used as the only lesson to, you know, work towards these standards. But this unit is having the kids practice their skills working towards these standards. So in 4th grade, using place value understanding to round multi-digit whole numbers to any place. This is a great opportunity for them to practice this. And also using place value understanding to round decimals to any place. So that's just the next grade up. So these are both numbers and operations in base 10, which is that larger category within Common Core. There's other opportunities for them to engage in math in this lesson overall, but just looking at this this video clip that we pulled in particular, this is where the students were practicing. This is the standard the students were practicing. Okay, so now that we have looked at 2 different scenarios, watched a classroom video, thought about the skills that the students are working on and developing, I want to give us a chance to apply some of the things that we are learning and look at one final scenario. So in this last scenario, you are going to actually be able to offer some suggestions to the teacher who has written this, this lesson sequence. So as you read this scenario, I want you to consider which subjects are being integrated. So I'm not going to tell you this time which subjects are being integrated. Well, I think I kind of am actually. But I want you to think about which ones are actually being integrated. I'll tell you what this teacher thinks is being integrated. And then I want you to think about, again, does the inclusion of these subjects add value to the lesson? And we don't want to stop at the yes or no question. I want you to back it up. Why are you doing that? I think, why do you think that it's the inclusion of these subjects add value, or why don't you think that? So for scenario 3, where we're going to practice, we've also added another pod here. So I'm just going to go through what's in this layout before I give you time to read. So up here, again, on the top of your screen, we just have our PowerPoint slide, just letting you know what you're considering. And again, when you're done reading the scenario, you're going to change your status to agree. We have our new scenario. This is a weather lesson sequence for grade 3. These are the standards that the teacher is hoping to integrate into their lesson experience. And then we also have a list of attributes of meaningful integration. So you can scroll up and down this. This is a list that I think connects really well with a lot of things you were saying. We took some of your comments from our previous discussion and we've added it to this list. So this is just here to give you some things to think about as you're determining if you think this lesson sequence is integrated or not. So the teacher in this is looking to use science, their science standards, to represent data in tables and graphically display the described typical weather conditions. So they're looking at some weather standards. In math, the teacher wants to generate measurement data by measuring lengths using rulers marked by halves. So some measurement skills, and then also some engineering, defining a simple design problem by reflecting on a need or want that includes specific criteria. So this teacher's really looking at a lot of things that they want to integrate. And this is the lesson that they have created. So I'm going to give everybody some time at this point. I will mute my mic for a couple of seconds, for about a minute or so, to allow people a chance to read. Again, once you're done reading, please change your status to agree so I know that we can move on. And again, as you're reading through it and you're thinking about those questions that I've posed, you can also refer to the attributes of meaningfully integrated lessons, which is a list that you helped us generate today. So I'm going to mute myself to give you some silence while you read. Again, if you've finished reading through this scenario, if you can change your status to agree so we know we can move on to our next layout. So in this layout, I've just shrunk the size of the scenario a little smaller so that way I can put these polls above it. I'm going to give everybody a chance to answer before we broadcast our thoughts. So I want you to think about what subjects are integrated meaningfully. That's your poll on your left-hand side. And which subjects are not integrated meaningfully. That's going to be your poll on the right-hand side. So we're going to leave it so you can't see what people are saying for a couple seconds because I want to give people a chance to put their thoughts down before I kind of reveal it so we can see. Okay. going to give people a few more seconds because I think we're missing some people on the not so, on the which subjects are not integrated meaningfully. Okay, so let's see. So for which subjects are integrated meaningfully, as you can now see, a lot of you are saying that math is really well integrated, or at least a lot of you are. And then science seems to be second in this situation. If we look at the poll on the right-hand side, it's almost like an inverse of our poll on the left-hand side, which is really interesting, and I like that. So again, it seems like a lot of people are saying that maybe the engineering isn't so integrated in this experience for the students. On both sides, it seems like we're split about 50-50 though on our science. So let's talk a little bit about what this means, or what your thoughts are. So what are some recommendations for teachers? So a lot of you said that the engineering wasn't well integrated in this unit, or maybe could be integrated better. So I want you to think about what are some suggestions you would have for this teacher to improve the integration of one of the subjects you thought were not as well integrated. You can also add in some of your thoughts of what you thought was really great, because we know that when we give feedback to people, sometimes it's really nice to start with a nice positive of, I really liked this aspect, I thought it was well integrated, but I think, if you worked here, that might be better. This poll is a little different than our chat pod, just to let you guys know ahead of time. You can only put one answer in. So if you type something new in, you're going to lose what you currently have typed in. So the best way to do this is just add a comma, write run-on sentences. It's okay. You can kind of just expand on your initial thought. So we have one recommendation overall. Somebody's saying that there really might not be an overarching problem for the students to solve. They're just kind of doing a little bit of math, a little bit of science, a little bit of engineering, but maybe that cohesion that we were talking about earlier in this webinar, maybe that's what's missing. I like the recommendation of maybe the students should collect and analyze their own data after they create a rain gauge, rather than using the predetermined data. I'm almost wondering if maybe they practice with the predetermined data, then make a rain gauge, and then collect their own might work as well. But right, exactly, let's use that rain gauge that they're creating. It almost seems like just something that was tacked on at the end, that maybe the teacher's administrator said, don't forget to add the engineering component, and the teacher was like, oh, okay, we'll just make a rain gauge at the end. So I really like the recommendation of let's actually use the rain gauge itself. Okay, somebody's saying maybe add a little more science. I think that's a really good point. Maybe, connecting a little bit more to science. Maybe this lesson in the lesson sequence doesn't have as much of the strong science connection. Maybe yesterday's lesson had a little more science in it. So I think a lot of you make some really great points, and I know here at Engineering is Elementary, when we look at this lesson, we agree with a lot of what you're saying. Is this one might not have the same cohesion as the other experiences did. It's still a really interesting lesson, but it might just need a little bit of tweaking to get it to that meaningful area, to really make it purposeful and to connect it back to the students' real world experience. Let's actually collect some data. Let's learn about what a scientist does, and then let's be a scientist. Let's collect that data and talk about it. Okay, so thank you. I think these are all really great recommendations. Right, maybe adding a little more math in there. If you want to add some fractions, engineering seems to be an add-on. Right, maybe this is a review activity. Maybe this is something they're coming back to later. That's the hard thing when we're assessing lessons. We know as teachers that a lesson taken on its own is just not the whole picture. It's really hard to assess one individual lesson because we know that we teach in these larger units, and that's what puts a lot of the context into the experience for the students. So maybe we're just looking at too small of an experience to get a good picture. But I'm loving these recommendations. I love the thinking that you guys have. I'm going to move us on. So thank you very much, everybody, for your thoughts. So as we come to the end of our webinar, and you guys can continue to kind of add your thoughts to the chat pod there, I'm going to share some additional resources that support integration. Those of you who attended the ELA webinar this morning, there's going to be a lot of overlap between these resources and the other ones, but there is also some, I think, one or two unique pieces. So those of you who joined us this morning saw this as well. This was created by NGSS at NSTA. This is a really great tool, I think, as a teacher when you're trying to figure out where math, science, and ELA overlap. So these are the math practices from Common Core, the science and engineering practices from NGSS, and the ELA student capacities from Common Core. So you can see that a lot of it mixes in the middle there where the students are constructing arguments, engaging in arguments, building strong persuasive essays. So I think I always like looking at this when I'm trying to think about where the subjects overlap in those skills. One other place I would recommend looking, so in NGSS, if you have a copy of the actual books, there's the spiral bound piece, which are your standards. Your performance expectations, your DCIs, all of those things. If you have that second book, which is just a regular book, that's your appendix. All of these things are also available online, so you can use that website there to access them. But in Appendix L, you'll find connections to Common Core, State Standards, Mathematics. So you can see how Next Generation matches up with the math standards. I highly recommend taking a look at the appendix. There's a lot of stuff there. Also on our website, we have some really great resources for you. So whether you're using, if you're using engineering as elementary in your classroom already, this will help supplement or support those things. And these are all free and available on our website. So if you go to the EIE curriculum tab at the top of our website, which is EIE.org, that'll bring you to this page. Well, it'll bring you to the yellow tab pages. You can click on the resources button and then it'll bring you to this page. Here we have some some videos in our library, so you can observe some of the students practicing their skills. So the video that I showed you earlier from the Parachutes unit came from our website, Classroom Videos. Content Area Connections is another great place to explore. This is a long way down designing parachutes. This is a math extension that a teacher has written and contributed to our catalog on our website. So this connects really well with Lesson 1, 3, and 4 in our unit, and you can see that the teacher has included the strands, so it connects to your measurement and data strands, your expressions and equations, and your mathematical practices. So there's a lot of great information here, a lot to explore if you're looking to integrate more subjects into your engineering, or if you're looking to integrate engineering into your subjects. Two other great resources as you explore our website are our literacy and our science resources. So if you're looking to draw connections there or add to your classroom library, these are some great resources to look through. And then standards. And we know that this is really important, so we have a page devoted just to standards. And if you click on that page, you can scroll to, we have our Next Generation Science Standards, the IT EEA standards, which are for technological literacy, but this third bullet point down are the science standards for all 50 states and Washington, D.C. So if you're interested to see how Engineering is Elementary correlates to your state standards, you can take a look there. And that might help you with integration. So just a reminder, Engineering is Elementary is an engineering curriculum, but it complements and supports and extends science subjects, science content that you're already teaching in the classroom, and it reinforces those math skills that your students are working on. So highly recommend taking a look there. So our last thing I want us to do, now that you have had a chance to discuss integration with me, and I appreciate all of the comments you have given me, and I've shared some of the resources we have on our website, I want you to think about what is one strategy you will use to meaningfully integrate lessons going forward in this new school year. So again, this is the attributes of meaningful integration that we have contributed to today. So we have discussed a lot of real-world connections, being relatable to your local community. So is there one of these areas that you really want to focus on going forward in your classroom? So you have a chance to add that to our poll on the right-hand side. I'll give everybody a chance to contribute. What are your thoughts? How are you going to take what we've discussed today and apply it to your practice? Give everybody a chance to type in. This one's a little harder because I can't actually see if you're typing in or not. Great. Okay, so we have one person contributed. So really they're going to focus in on that, connecting to the real world experiences. Maybe, you know, connecting it to their local environment, making the lessons relevant to the students. You know, we want them to see this in context, and if we give them engineering experiences that are relevant to them, they start to self-identify as engineers themselves, which is something we want our students to walk away with. Encouraging your students to apply their math and science skills to become informed designers. That is great. Applying this for science fair projects, STEM projects. Taking another look at your lessons and seeing if your math standards are integrated. I think that's wonderful. That sounds like a huge project, but I think that that is really going to be a great way to move forward. It's always good at the beginning of the year to think about how can I improve the lesson experiences that I have for my students? Have I learned something new this year that I can, you know, add in? So maybe reflecting on a couple of your lessons this year and just looking to see, is it meaningfully integrated? And if it is, great. If it's sort of, this is a great opportunity for you to improve on your integration. All right, thank you very much, everyone. I'm going to move us to our wrap-up layout because we have 2 minutes left, but I can stick around if anybody has any questions. So feel free to jot any questions down in that pod. I'm just going to share some final information. First thing I'm going to do, being that we are basically at the end, I am going to push all of you out to our webinar survey. This is going to either open up in front of your screen or behind your screen. If it opens up in front and you're not ready to move to the survey, just minimize it and you can go back to it at the end. If it doesn't open in front of your screen, most likely it opened behind your screen. So when we're done here and we close it down, just don't forget to fill it out. We do use that information to support the updates we make to our webinars. For those of you who have been with me all week, you know that we have 2 more webinars tomorrow. So yesterday was our Getting Started series. Today we focused in on integration, and tomorrow we're going to focus in on pedagogy. We're going to be thinking about questioning strategies to engage students in the improvement of their technologies. We're also going to think about what we want to do to help our students think more like engineers. So if you haven't already registered for those 2 that are coming up tomorrow, I'm going to push you to our registration page. Again, it might open in front or behind. If you're already registered, feel free to close it If you haven't and you would like to, definitely register for this now. We will be archiving all of our videos. We've been recording everything this week. We will be working to archive them sometime in the next week or so. So they should be up on our website in about 2 weeks. To access them, you just have to go to eie.org/onlinepd. That will bring you to our main page. You scroll all the way to the bottom and there's a link that says watch videos. That will take you to our YouTube page. We keep the videos there updated, so we only show the most recent webinars that we have recorded. So all of this will be there shortly. Some other thoughts. If you already are using EIE, wonderful, great. Hopefully you see a lot of connections with what we talked about today to what you're doing. If you don't use Engineering as Elementary and you're interested in learning more, this is some information you can, take down. You can also go to our website. Again, it's eie.org. All right, thank you, everybody. Yes, thank you for joining me again. I know a lot of you have been here for all 4 of these sessions, and this has been a great experience so far. If you have any questions, I am going to stick around in the room because I know we went to basically the end of the session, and I want to give people an opportunity to ask me questions before I close. So I'm just going to hang out here for maybe 2 or 3 more minutes. Feel free to ask me any questions you might have. Hopefully I will get a chance to see some of you again tomorrow for our 2 webinars then. But thank you very much. And yeah, hopefully this will get everybody excited and ready for their new school year, whether you're starting your new school year next week or if you're starting your new school year closer to September. Hopefully these are things that will help you prepare as you go forward. All right, I'm going to stay in the classroom. I am just going to pause my webcam though at this point. But I'm still here in the classroom, so feel free to type in any questions you have. Oh, Lisa, I'm glad you enjoyed it. Right now, we don't have any more webinars on our calendar, but as we start to add more things, you can also go to our webinar page, and our information will be there. We decided to run a nice long week. Oh, there it is, right there. That's our page. This summer we decided to run all 6 of our webinars in a week to hopefully accommodate as many time zones as possible, because we know that sometimes when we offer afternoon webinars here in Massachusetts, it doesn't always work so well for people who are on the West Coast. So we planned them all in one shot right now, but as we look at our fall schedule, I'm sure we'll be adding things to our calendar as we go along. So definitely check back there. Yeah, and thank you for coming. And like I said, we're going to be archiving everything that we've done, so any of the webinars that you miss, you can watch at your own time at a later point. Okay, so we're about 4 minutes over, and it looks like we don't have any questions. So unless you have a question and you can type really fast and get it into me, we are going to actually close the classroom in about 30 seconds. So thank you again, everybody who attended today. Hopefully you are super excited about implementing some of this in your classroom this school year. And those of you who are joining me tomorrow morning, I look forward to working with you again. All right, goodbye.